welcome to Maths 211 class. So today we are going to take the first unit. Don't forget, this is differential equation. So it has three modules. Module 1 is first order ordinary differential equation. Module 2 we deal with Laplace transform, and in module 3 we discuss partial differential equation. So we are starting with module 1 unit 1 today. So we are looking at first order differential equation. Normally in this course we are going to be abbreviating our differential equation as DE. So when I say first order DE, I mean first order differential equation. So we want to look at some basic definitions before we go ahead today. We want to define what a differential equation is. An equation of the form f of x, y, y prime, y prime prime, dot 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 is called a differential equation where x, this x I underline, denotes the independent variable, y denotes the dependent variable, and y prime denotes the first derivative of the dependent variable with respect to the independent variable. Y prime prime denotes the second order derivative of the dependent variable with respect to the independent variable, and so on. Thus, an example of ordinary differential equation is of the form dy dx plus xy is equals to 0. In this case, we have dy dx as the first order differential equation, and x being the independent variable and y being the dependent variable. So this is an example of first order differential equation. Also, another example is of the form xy d square y dx square plus y dy dx plus exponential 3x equals to 0. In this case, the derivative, the higher order derivative is the second order, and we have this. So this is an example of second order differential equation. So now, before we move ahead, let's define some other terminologies that we are going to be using in this course. We have order of a differential equation. What do we mean by order? An order of an ODE is the highest derivative involved in the differential equation. For example, the two examples we looked at earlier. Number 1, where we have dy dx plus xy equals to 0, and number 2 we have xy d square y dx square plus y dy dx plus exponential 3x equals to 0. The first example here is of order 1. Why? Because the highest derivative that I circle here is the first order differential equation. So we call this one first order differential equation. Now the second example here, because of the presence of this d square y dx square, this is an example of second order differential equation. If you have a differential equation that contains d cube y dx cube, then that should be the third order. Also, we have to define another term, and we call it the degree of a differential equation. By degree, we mean what is the index, the power on the highest derivative that is present in the equation. So the degree of an ODE is the index on the highest derivative after removing the radical sign and fraction. Let's take, for example, the dy dx plus xy equals to 0. When you look at this, this is the highest differential coefficient in this equation, so it is of first order. And by the time you look at this dy dx is just having the index of 1. So it is also of first degree. Similarly, if you have xy d square y dx square plus y dy dx plus exponential 3x equals to 0. This is the highest derivative there, so it is second order, and the index on this is first, so it is second order first degree. Let me give you an example of a differential equation that is not of degree 1. Consider a differential equation of the form d square y dx square raised power 3 minus y raised power 3 over 2 equals to 2 sine x. So by the time you look at this is a differential equation of second order because of this, the highest derivative, and the power on the second order is 3, so it is third degree. So the degree of a differential equation has to deal with the index on the highest order derivative present in an equation. So we still have another terminology we want to discuss briefly, and that is classification of a DE. So any ordinary differential equation can be classified into two. It can either be linear or non-linear. How do you know when it is linear and when it is non-linear? Any differential equation is said to be a linear differential equation if both dependent and independent variable occurs to the first degree only, and there is no product of dependent variable and or its derivative. Let's take, for example, if we have d cube y ds cube plus x square d square y dx square plus x raised to power 4 dy dx plus is equals to x exponential 3x, let's say plus y. By the time you look at this differential equation, this is differential equation of third order because of this. It is third order. It is first degree because the index here is 1. First degree. And by the time you look through all the equations, there is nowhere where y is multiplying the derivative, or where any of the derivative carry an index that is greater than 1. Hence, this equation is said to be a linear equation. Let's now take, for example, also an equation of the form d square y dx square plus dy dx all square plus y half is equals to 0. This is a second order differential equation because of the presence of this second order first degree. Why is it first degree? Because the index on the highest derivative here is 1. But this is non-linear. Reason being that there is a product of dy dx and dy dx. So this is non-linear. So anywhere you see a product of either the dependent variable and its derivative, or a dependent variable multiply the dependent variable, then such an equation is said to be non-linear. And with this, we have come to the end of Unit 1. I hope you are going to go through the tutor-marked assignment, the self-assessment question, and you are going to go through it and also do your tutor-marked assignment. By next class, we will be looking at some solution of first-order ordinary differential equation. Till then, have a nice day.